Sir, class, this is Cadet Ungrady and Cadet Milton here to brief our final project of NHL scouting for SC370. The problem at hand is that we are two NHL talent scouts trying to determine which players can perform under pressure and in clutch situations. A lot of the times, NHL scouts look at hockey players and give them value based off of normal categories such as number of goals scored, how quickly they can get from one side to the other of the ice. But we want to look at unusual categories that people may not necessarily look at, such as which players can score backhanded or which players can score from behind the net. We also want to see which players can perform under pressure in clutch situations. For example, which players are able to win face-offs in the third period when the pressure is higher and the game's on the line versus the first two periods. So that's what we wanted to do as NHL talent scouts and analyze players based off of these unusual categories.
Sir Class, this is Cadet Bryce Milton. I'm going to be briefing you on problem 1A. So basically what we're trying to find out for the first problem is determining which players win face-offs when shorthanded. And for those of you who aren't hockey enthusiasts, shorthanded is when a penalty occurs and you are down a player for an extended amount of time, usually 2 to 5 minutes. So we start by reading in our data, which is hockey data. And we had to use a package called Ungrady, which makes it easier to work with time. So we changed our time from hours, minutes, seconds to just seconds to make it easy to work with. And then we had to do some other manipulation and reassigning to basically get the time to go all the way throughout a game consecutively without resetting. So then we have the only game function where we use the unique function to basically it's going to read every single only game is going to read the game ID as every individual game, and then the final game is just a list of all the only games at the end that we're going to have output. So basically what this code is going to do is it's going to go through every single game individually, and every time there's a penalty it's going to mark that off and then search up after it finds the penalty length, and every time there's a face-off within that penalty length, which means that they're shorthanded, it's going to mark down the winners and the losers of that face-off. And if they're a winner, it's going to give them a 1. If they lost, then you give them a 0. And then basically, if there is a power play game or a power play move within that time increment of the penalty, then the penalty is removed. So it's going to start from that PPG and it's going to erase everything below it, and this keeps shortening itself until it finds a face-off within that specific penalty time frame. And then after that, it's going to output our final game is going to output 3 columns. Basically, it has everyone's name, their attempts of a shorthanded face-off, their wins, and their win percentage, and which is what we have outputted right down here, which is just the top 10, and there's about 697 more rows. But you can see all top 10s have all been in shorthanded face-offs, and they have a 100% win advantage of it. Next will be followed by Cadet Ungrady.
Moving on, we wanted to see which players are able to win face-offs at a higher rate compared between the third period and the first 2 periods. So we began this process by reading in the data and filtering by player name, the period, and the result of the face-off. We were doing the first bit only in period 3, so we had to filter in the third period initially. We decided to make 2 data frames for winners and for losers because it would be easier to join the 2 groups together. And then after joining the 2, we were able to add another column, which is essentially the sum of the face-offs, either winning or losing, that each player had. Once we had this column, we were able to divide the frequency that a person won a face-off in the third period by their total number of face-offs in the third period, which gave us the percentage of wins. And then we did the same process for periods 1 and 2, moving all the way down into making a percentage of how many wins they get in the first 2 periods. And after that, we had to join both of those data frames together, and from there filter down that data frame to only the top 10, and adding a column called differential, which you see down here. Essentially, which players had a bigger difference between their win percentage in the third period and the first two periods. As you can see here, David Bakes was first with 15%, followed by Lindbergh, which is 12%, and so on and so forth. So you can see David Bakes has the highest win percentage in the third period compared to his first two periods. We also visualized this data with the ggplot right here, interactive ggplot. This is an easier way to visualize the data, and we can see that David Bakes has a significant advantage in the third period of face-offs compared to the other two periods and the other players in this category as well. Moving on, we wanted to see which positions these players play, so we used hockeyreference.com and were able to web scrape all the positions of every hockey player in the NHL, and from there we pared down that information to just the players that are in this data set. So we had, once we got the positions of each of these players, we were able to add that column as well at the very back of the list. As you can see here, most of the players are centers, and only two of them are a left winger and a right winger. Therefore, moving forward with recruiting in the NHL, you should try to look out for forward-playing NHL players and mainly centers, because that's where we get most of our win percentage in the third period from.
So for problem 2, they're actually relatively easy, but I'll just start with the first one for now. What we want to look is for players that score the most backhanded goals in a season. So what we did to do that is we read in the hockey data, and we resulted by we filtered by result event, which is specifically just the goals within the season, and then so that gives us all the goals in a data frame. And then we also did a filter with result secondary type, which is backhand. So this new backhanded data frame is going to give us all the backhanded goals in the data frame. So then we counted that data frame by the result event, which is goals by players type scores, which is going to give us a list of all the names of the athletes who scored a backhanded goal and the amount of times they've done that. And then basically we just cleaned up the data right here. We just selected the type score and which is represented by goals. We changed the column names and then called it. And you can see Patrick Kane has the most goals, then Pavel Datsyuk, and Jonathan Toews. So for part 2B, same thing, just a little bit different. We had to find the players who scored from behind the net the most, and we can do that by using the X and Y coordinates from where the goal was shot at that we were given in a data frame. So we did the same exact thing as the last problem. We selected result event, X, Y coordinates, and the person who scored, filtered the goal, filtered to, and then the length of a hockey rink is 200 feet long, and the hockey goals start at 89 feet on both ends. So we filtered the X coordinate to be greater than 89 and then less than negative 89, and that gives us all the goals from behind the net. We used the count function to count that by the player type scores, change the column names, and we got this as an output, which has John Tavares scoring the most goals, and then it goes down to Brendan Gallagher and Dustin Byfuglien. So on to our Shiny app. So we took our Shiny app down to basically what we did for problem 2A and 2B. And the way we did it is we made these two tabs, which you can see is goals scored from behind the net and goals scored backhand. You can actually pick your season right here. We did seasons 2013, 14, and 15. And as you pick the season, it's going to show all the goals on this hockey rink that we have right here. And on below it, it's going to show all the players who scored those goals during that season for that specific year. And the same thing with backhand right here. It goes from 2013 to 2015. It also shows the players at the end. Thank you for listening to our video, and I hope you like it.
That concludes our brief.
Go Army.